Hi everybody, this is a quick little lesson on acceleration. Seeing as I'm not there to personally go over this with you, I'd like you to watch this video as carefully as you can while you're looking at your notes, and hopefully this video will help you complete the word problems and the graphs from your graph worksheet. So basically, I would, like I said, would like you to have your notes with you. If you don't have them with you, just follow along and share with somebody next to you. It's really important that you follow along in your notes in order to better understand them. And you can also follow along in your book if you don't have your notes with you. So just very quickly, acceleration, as we briefly discussed when you were preparing for the lab that we will eventually do together this week. Acceleration is basically just a way that we measure a change in speed or velocity. So acceleration, we're right here, is the rate at which speed increases or decreases, or there's a change in direction, and I will explain that. Now, we typically use the term acceleration when speed increases. However, the term deceleration, or we can say a negative acceleration, is happening when speed decreases. So that's also considered acceleration. Now, acceleration can also be defined as changing direction. For now, I just want you to pause and not think about that too much, and we'll talk about it when I'm in school later this week. Now, how do we actually calculate or measure acceleration? So acceleration is basically measured by calculating or subtracting the change in velocity or the change in speed and dividing it by the amount of time that it took for that speed to change. Now, what's that? Basically, you take your final speed and your initial speed, find the difference, and then divide by the time it took for that speed to change. So for example, I have a car that is traveling at 100 meters per second. And within a matter of 20 seconds, he went from 100 meters per second to 160 meters per second. So how do I calculate my acceleration using the equation that you saw earlier? So if we do acceleration is equal final velocity minus the initial velocity divided by the time. This is the equation that you're going to see in your textbook. So again, final velocity minus initial velocity divided by the time. So let's look at my problem again. My final velocity was 160 meters per second. So I'm going to do 160 minus my initial velocity. So the car started, when I started measuring the time, the car was already going 100 meters per second. Your initial velocity can easily be 0, and that's okay. So again, going back to my equation, final velocity, 160, minus initial velocity, 100, divided by the amount of time that it took that change to happen, divided by the time, which is 20 seconds. So then I get 60 divided by 20, which is equal to 3 meters per second squared. What does that mean? Look at my unit here. It's meters per second squared. This essentially means that for every second, my speed changed 3 meters per second. So what this is saying is basically this. Look at this. Every second, my speed changed by 3 meters per second. Every second, my speed changed by 3 meters per second. I'm going to go over this later on this week as well. But acceleration is another type of rate. And like I said, I'm going to go through it in more detail when I get back. So just let's review this for a second. So if we go back, I have a car that goes from 100 meters per second to 160 meters per second, and I want to calculate its acceleration. Acceleration, again, means either an increase in speed or a decrease in speed. So if we want to measure the change in its speed for a certain amount of time. So again, my car goes from 100 meters per second to 160 meters per second in 20 seconds. How will I calculate the acceleration? I look at my formula, final velocity minus initial velocity divided by the time. My final velocity was 160 minus my initial velocity. Initial means the starting velocity divided by the amount of time, which was 20 seconds. 60 divided by 20 is 3 meters per second squared. And I'm going to talk about the units a little bit when I get back. Remember, it's a rate, and it's the amount that the speed changes in a certain unit of time. Now what I'm going to ask you to do is do the next page in your notes, and you're basically just going to complete these problems. The first ones are really straightforward. The numbers are given to you. So the initial velocity is here, final velocity. So you're using the equation again, remember? Acceleration is equal to final velocity minus initial velocity divided by the time. So if we do the first one together, it's 24 minus 0 divided by 3. 24 divided by 3 is equal to 8 meters per second squared. Okay, so you're just going to do that for the rest. And sorry, the format here is a little messed up because of the video. Once you have completed these, just make sure to complete the problems. Make sure to complete the problems that follow. These are pretty similar to the problems that you completed on when you were calculating speed. Of course, these are a matter of calculating acceleration, so you'll have problems while you actually have to calculate acceleration. For example, like number 7, a car accelerates from 25 to 155 in 2 hours. What is acceleration? You'll use your formula. Whereas there may be problems like number 8, where you're given the acceleration, you're given the initial velocity, and you have to determine the final velocity after 30 seconds. You try your best. You can talk to people next to you to try to figure them out. As long as you're keeping the noise level down and that you're on task, I really don't have a problem with that. Once you finish those problems, then you go to your graphing worksheet and you complete the speed versus time graphs. Now I'm having a little bit of trouble here with the document on the video, so you just make sure that you go to the pages where it says speed versus time. Okay, some of you already started those, and that's great if you did. Just make sure that you also answer the 3 or 4 questions that are at the bottom of the page. Again, you try your best based on the video that you saw today and based on any help that you can get from your textbook. Once you have finished those problems, you move to your graphs worksheet. So you've already completed the first 2 graphs that were speed versus time. Now you're going to complete the rest of that worksheet, and it's all, you've already completed the worksheets that were distance versus time. Now you're going to complete all the graphs that are speed versus time. Now I'm having a lot of trouble with the format here on the video, so just make sure that on the top of your sheet it says speed versus time and not distance versus time. Some of you had already started those. That's great. Just make sure you finish all those graphs as well as all the questions that are at the bottom. Again, try your best based on what you saw in the video and based on your notes and whatever information you have in your textbook. Everything must be handed in, so make sure your names are on everything and you hand in everything, whether or not you have finished to the substitute teacher.